Good evening, everyone. Welcome to the lectures of engineering mechanics. Now, although it is the second lecture of engineering mechanics, but technically it should be the first, because in the last class we just had an introduction of engineering mechanics. I told you about the syllabus, I told you about the books, I told you about how these chapters are divided, I told you about how we are going to proceed with this subject, right? So this is officially the first lecture of engineering mechanics, you can say, because from this point onwards we are going to discuss all the theories, all the concepts, all the numericals. Good evening, a very warm welcome to all of you. Good evening, good evening, good evening, good evening. Chalo, so let's begin. Now, those of you who have missed last lecture and who don't know me, let me introduce myself again. My name is Aprup Rao, All India rank 320 in Gate Mechanical in my first attempt. M.Tech from IIT Kharagpur, my specialization was Mechanical Systems Design. Then I was placed at Mahindra and Mahindra Research Valley, where I worked for 2 years. I was part of some really interesting projects. I was working in the research and development department. Then after that, I started my teaching career. So I've been teaching for more than 8 years now. And my favorite subjects to teach are engineering mechanics, strength of materials, machine design, theory of machines, vibrations, etc. All the subjects of design. Okay. Now, in the last class, I told you about how we have divided all these chapters. And today we are going to start with the first chapter, which is the basic concepts. Now, in this chapter, we are going to talk about the basic concepts of forces, moments, resultant of forces, how the force system works, how moment is calculated, Newton's laws of motion, principle of transmissibility, Varignon's theorem. So all the basic concepts related to forces, moments, etc. Then after that, we will start with equilibrium, friction, truss, etc. So let's begin the first chapter, basic concepts. Okay, and we are going to start with basics, A, B, C, D. I will assume that you know nothing about engineering mechanics. I will even tell you the definition of force. I will even tell you how the vectors are added. So we are going to start this course from the basics, from A, B, C, D, and we will go to the X, Y, Z. Okay, so we'll start from zero and I will bring you to the hero level concepts of engineering mechanics. Now, who can watch these lectures? The students who are preparing for GATE, engineering services, SSC, AE, JE, or even if you are preparing for your semester exams, if you find these chapters relevant to your exam, then you can study these subjects, you can watch these lectures. Okay, so let's begin the first lecture of basic concepts. In today's lecture, we are going to talk about the force. I will define what exactly is force, and let me tell you, you might have not studied the definition of force like this. I will tell you exactly what do we mean by force. Then we will talk about the principle of transmissibility of forces, a very important principle. I will tell you what is the significance of this principle. You might have known about principle of transmissibility, but I will tell you the significance of this. And then we will talk about the vector addition of forces, the basic concept of resultant, finding the resultant. Okay, so shall we begin with the definition of force, because this is the most important concept of statics. Chalo. Now, if I ask you, we all know about forces, right? We all know what force is. But if I ask you to define the force, you might not find the appropriate words, right? Defining the force, defining the very basic concept of force, it's difficult in words. But if I tell you what exactly is force in general words, then it is interaction between two bodies. And this is a very relatable definition of force. Force is nothing but interaction between two bodies. Now let me give you an example. Being a mechanical engineer, you are going to talk about machines. You are going to design machines. And if you are a civil engineer, you are going to design structures. Be it a machine member or a structural member, every member is connected to several other members, right? If we talk about structure, look at your house. Look at the room that you are in. Consider any one member. Let's consider the beam. that beam is connected to the roof, the walls, the columns. So it is interacting with all these members, right? The beam is interacting with all these members. Now, what do we mean by force? It is a way of showing this interaction. For example, if I talk about the interaction between the roof and the beam, the roof is supported on this beam, right? So the roof is applying a downward force on the beam. If I draw the free body diagram of the beam, I will show the interaction of roof with the beam with a downward force like this. So what is force? It is a way of showing the interaction between two bodies. For example, let's say I put my calculator on top of my hand. Okay. Now if I draw the diagram of my hand, not the calculator, just my hand, and I want to show how this calculator is interacting with my hand, what am I going to draw? This calculator is putting all its weight on top of my hand. It means that this calculator is applying a downward force on my hand. So I will show the interaction between this calculator and my hand with a downward force. So force is nothing but showing the interaction. It is a way of showing the interaction between two bodies, whether these bodies are pulling each other or pushing each other or rubbing each other or trying to rotate each other. So this interaction is shown by forces. Okay. Now if I define it in technical terms, if I define it in technical words, then force is the action of one body on another body that tries to change the motion of the other body. Understand this definition. Force is the action of one body on another body that tries to change the motion of the other body. Tries to change. First of all, changing the motion. What does it mean? Changing the motion means if a body is at rest, then the force will try to move the body. And if the body is already moving, then the force will try to change the velocity of this body. Let's say if it is moving with 10 meter per second, the force will try to move it with 20 meter per second or 5 meter per second. So trying to change the motion means, changing the motion means, if it is at rest, it will try to move it, or if it is already moving, it will try to change the velocity. Now I am saying trying to. It means that it is not necessary that the motion will change. For example, if I put a calculator on top of my hand, the calculator is trying to move my hand downward, but my hand is not actually moving. It is still there, right? So it is just trying to change the motion of my hand, not actually changing. It is trying. Okay, it is trying. It might happen, it might not happen, but it is trying to change the motion of the body. So I hope you understand exactly what force is, right? It is a way of showing interaction between two bodies. A body is trying to change the motion of another body. Whenever these bodies are interacting with each other, they are trying to change the motion of each other. Okay, they are pulling each other, pushing each other, rubbing each other. So trying to change the motion of each other. Okay. Now, force is basically a vector quantity. What do we mean by vector quantities? See, quantities, physical quantities, they are divided into two types. Although there is a third category, but I am not going to talk about that third category. So basically, all these physical quantities are divided into two categories: scalar quantities, vector quantities. What do we mean by scalar quantities? Scalar quantities are those quantities which do not require any direction. For example, if I say that the weight of this pen is 100 grams, I will only give you the magnitude of the weight. I will only give you the magnitude of this mass. I'm sorry, I'm not saying weight, mass. So if I say that mass of this body is 100 grams, it means it has a magnitude of 100 grams. It doesn't have any direction. I'm not saying that the mass is 100 gram in Y direction or X direction or Z direction. So when we talk about mass of a body, 100 grams, 1 kg, 2 kg, 10 kg, it doesn't have any direction. It just has magnitude. So it is a scalar quantity. But if I talk about force, velocity, acceleration, these are vector quantities which require direction. So force is a vector quantity which is characterized by three things. If you want to define a force, if you want to show a force, you need these three things: magnitude, point of application, and line of action. What do we mean by line of action? It is showing the direction. Okay. For example, let's say that we have a body like this. It is subjected to a force. So in order to show that force, I will need three things: magnitude, point of application, and direction or line of action. So let's say I am showing that force like this. Okay. Now magnitude of this force is shown in newtons. The SI unit of the force is Newton. So let's say the force acting here is of 100 Newton. So what is this 100 Newton? It is the magnitude of the force. Okay. Point of application is, let's say, this. It is acting at this particular point. So what is this? This is the point of application of the force. And what do we mean by line of action? This is known as the line of action. What is this? This is known as the line of action, which is just showing you the direction of this force. This line is showing you the direction of this force, that the force is acting in this direction. Okay. So in order to define force, you need these three things. You need magnitude, you need point of application, and you need line of action or direction of the force. You can also show a force by using vector. For example, let's say that I show the force like this. I am denoting the force by F and I write it like this: 50I plus 30J minus 20K, where I, J and K are unit vectors in X, Y and Z. What is I? Unit vector in X direction. Okay. Now what do we mean by unit vector? So understand, unit vector means the magnitude of this vector is 1. Okay. So if I say 50I and I is a unit vector in X direction, it means that in X direction the net force is how much? 50 into 1, 50 Newton. I is 1 Newton in X direction. So in X direction, what is the total force? 50 Newton. Okay. Let's say that this is in Newton. So I is a unit vector in X direction, means in X direction total force will be 50 Newton. Now what is J? Similarly, J will be a unit vector in Y direction. K will be a unit vector in Z direction. Okay. So now you know that this force has a component of 40 Newton in X direction. It has a component of 30 Newton in Y direction, and it has a component of minus 20 Newton in Z direction. Okay. So we can show the force like this also. We can either show the force by an arrow, or we can show the force by using a vector. So if you show the force by a vector, it will be something like this: 50I plus 30J minus 20K, where I, J, K are what? They are unit vectors in X, Y, Z direction. Their magnitude is 1. So if I only write I, that means in X direction the force is how much? 1 Newton. Okay. So I, J, K are unit vectors in X, Y, Z direction. So the force in X direction is 50 Newton, in Y 30 Newton, in Z minus 20 Newton. I hope it is clear to you. Now, when we are characterizing the force, I told you that we need 3 things: magnitude, point of application and line of action, right? But in many cases, we don't need point of application. For example, in engineering mechanics, in this subject, we don't need the point of application. Why don't we need the point of application? We don't need the point at which exactly the force is acting. We need this line of action. We just need this line of action. We don't need the point of application. Okay, this must be 50 Newton, sorry. Thank you so much for correcting. Now, let me explain you why don't we need the point of application in engineering mechanics. I am not saying that you never need point of application of a force. In some subjects, you will need point of application. For example, in strength of materials, the point of application is going to matter. But in engineering mechanics, the point of application doesn't matter, and it has something to do with principle of transmissibility of force. Now, what is principle of transmissibility of force? Let's understand, and let me tell you, this is a very, very, very important concept related to forces, and you are going to use this concept in a lot of problems. Okay, so later on when we are going to solve those problems, I will tell you that yes, this is principle of transmissibility. So you must know this principle right now so that you will be able to relate it with that problem. So let's understand what is principle of transmissibility. The point of application of a force, according to this principle, the point of application of a force can be moved anywhere along the line of application of the force without changing the external effects of the force on the rigid body. Understand the meaning of this word. Understand the meaning of this sentence, sorry. According to this principle, they are saying that, let's say that we have a rigid body and there is a force acting on this rigid body like this. Okay. Now, right now, the point of application is this. Let me call this point of application as A. Okay, let's say this force is F. It is acting at point A. So, according to this principle, even if you move this point of application, even if you move this point of application from here to, let's say, here, it is not going to change the external effect of this body. The external effect will still remain the same. Now, what do we mean by external effect? External effect means any effect that you can see outside this body. For example, the velocity, the acceleration, the displacement, all these are external effects of the body, right? If I apply a force on a body and the body moves by 10 meters, then that displacement is what? It is an external effect. Okay. Whatever is happening inside the body, stresses are being developed inside the body, right? Stress is an internal phenomena. Okay, what is stress? That you study in another subject. So stresses are internal effect. They are happening inside the body. So that is an internal effect. So are you clear about the external and internal effect? Please tell me in the live chat. External effect means anything you can see from the outside. So the body is moving, I can see the displacement, I can see the velocity, I can see the acceleration, everything from outside. So they are all external effects. So it means that if I change the point of application from A to B along this line of action, okay, we can't change the point of application from A to C like this. No. That point must lie on this line of action. So even if I change the point along this line of action anywhere, it is not going to change the external effect. Let me give you a better example to exactly show you how the external effect is not changing, but the internal effect will change. I will tell you, if you move the point of application from A to B, it is not going to change the external effect, but it will change the internal effect. And to show that, I am going to use this example. Let's say that we have a body like this. Let me make a copy of this body. Now, let's say this body is subjected to equal and opposite forces along this line. Okay, this body is subjected to equal and opposite forces along this line. Let's say that one force is acting like this, one force is acting like this. Okay, let's say this is F1 and this is F2. F1 is equal to F2. So I am saying that we have two equal and opposite forces. Now let's say F1 is acting at point 1, F2 is acting at point 2. Okay. Now understand what I am going to do. What is the external effect of these forces? If F1 is equal to F2, what will be the external effect? If F1 is equal to F2, it means that there will be no displacement, right? Can I say that? Displacement in X will be equal to 0. Very good, very good. I can say that there will be no displacement, right? So this is the external effect. Okay. Now understand, if I move this force from point 1 to point 2, and if I move this force from point 2 to point 1, I have moved this force F1 from point 1 to point 2 and this force F2 from point 2 to point 1. Can you see that? Now this is F2 and this is F1. Now can you tell me what will be the external effect here? Still F1 is equal to F2. What will be the external effect here? Again 0. Very good, very good. Again the external effect remains same, 0 displacement. So what can we understand from this? What can we understand from this? Even if I move these forces along this line anywhere, the external effect remains same. Earlier it had 0 displacement, now also it has 0 displacement, but the internal effect is going to change. Now what is the internal effect? Internal effect means stress. Now you might know something about stress, right? Stress means what? Force upon area. Okay, although we need to go into detail in order to understand what is stress, but you must know that there is something called tensile stress and compressive stress. That you know, right? There is something called tensile stress and compressive stress, right? So beta, here which stress will be developed? Here which stress will be developed? In this case, which stress will be developed? Very good. There will be tensile stress. But here which stress will be developed? In the second case, which stress will be developed? In the second case, which stress will be developed? Very good, compressive. So you can see that although the external effects will remain same, the internal effects is changing. So in order to calculate the internal effect, you must consider the correct point of application. Is this clear or not? So in engineering mechanics, we are only dealing with the external effects. Hence, we can move the point of application along the line of action. But in strength of materials, we deal with internal effect. We cut the body and we look inside the material. What is happening? What stress is developed? So in that case, we can't change the point of application. In that case, if you change the point of application even along the line of action, then it will change the external effect. But in engineering mechanics, we are only dealing with external effect. We are not looking inside the body. We are just looking outside the body. What is happening to this body? Okay. So in that case, we don't need to consider the point of application. The point of application can move anywhere. I can show this arrow here. I can show this arrow here. I can show this arrow here. Anywhere along the line of application. Is this clear? Now you might be wondering, what is the significance of this principle of transmissibility of force? That you will understand when we will apply this principle. Right now, if I try to explain, now you will not understand. But when we will solve problems and we will actually use this principle, then you will be able to relate it. Oh, that is why we are using principle of transmissibility. That is why we studied principle of transmissibility. Okay. So, just be patient and wait for the actual application of this, then you will clearly understand why this principle is so important. Okay, right now you might be wondering why we are why we are moving this arrow. Even if this arrow is acting here, why does it matter? Why we are bothering to move this arrow anywhere? So you will not understand it right now. You will understand it when we will solve some problems. Okay, chalo. So after understanding principle of transmissibility, our next objective is to understand how two vectors are added together, because in almost all cases, the body will not be subjected by only one force, right? The body will be subjected to multiple forces. So in that case, you will have to add the forces. Adding the forces is also known as finding the resultant. Okay. For example, let's say if I add two scalar quantities, let's say 2 plus 3 kg, 2 kg plus 3 kg, it will be equal to 5 kg. So I can say that this 5 kg is the resultant of 2 kg and 3 kg. This is the addition, or you can say resultant. So in the same way, when we add two vectors, then the whatever product we get here, that product is known as the resultant. It is the addition of two forces. Okay. So let's understand the vector addition of two forces. Now this vector addition of two forces is governed by a law known as parallelogram law. We add two vectors by using this law. So let's understand what is parallelogram law. Now this is very important, beta. These basic concepts, we might think that why we are studying here, it's a waste of time. But beta, let me tell you that if you understand all these basic concepts and if you add all these basic concepts, then only you will be able to solve difficult problems, bigger problems, gate level problems. Okay. So try to understand each and every basic concept. Okay. Let's understand parallelogram law. Parallelogram, what do we mean by parallelogram? Parallelogram is this. It has parallel sides. Okay, opposite sides are parallel to each other. Okay, so this side and this side are parallel, this side and this side are parallel. This is known as a parallelogram. Okay, now understand parallelogram law. If two forces acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, their resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Understand it. According to this, let's say that we have two forces acting at a point. Let's say this is force 1. Okay. And this is a force 2. Let's say this is F1 and this is F2. There is an angle between them. Let's call this angle theta. So according to parallelogram law, if I represent F1 and F2 as two sides of parallelogram, then the diagonal of that parallelogram will be their resultant. So let me complete this parallelogram. So this will be the parallelogram, right? This will be the parallelogram. Now, what will be the diagonal of this parallelogram? This is going to be the diagonal. So this diagonal will be the resultant. Let me call this resultant R. This is known as the parallelogram law of addition of two force vectors. Now we can find the equation of this resultant by solving this. Okay. So what we are going to do in the next step is we are going to find an equation of R in terms of F1, F2 and theta, so that in later cases we will directly use this formula of R. Okay, so we are going to find a formula of R in terms of F1, F2 and theta. Okay, so let's understand how we are going to find this formula. Okay, I will also tell you the triangular law of addition of forces. Okay, triangle law and parallelogram law, they are one and the same thing. Okay, chalo, let's find out what is the formula of R in terms of F1, F2 and theta. Okay, now understand this. What I am going to do is, I am going to complete this. I will make a triangle like this. Okay. Now, if this is F2, then this is also F2, right? If this is F2, this is also F2. And if this is theta, then this is also theta. Yes, these two sides are parallel, na? So if this is F2, this is F2. If this angle is theta, this angle is also theta. Now what will be this? This will be F2 cos theta. And what will be this? This will be F2 sin theta. Right? Now look at this. Look at this triangle. Okay. Can we apply Pythagoras on this triangle? According to Pythagoras, can I write R square, this is the hypotenuse, equal to F1 plus F2 cos theta whole square plus F2 sin theta whole square? Hypotenuse, base, perpendicular. So according to Pythagoras, I can write this, right? R square equal to F1 plus F2 cos theta whole square plus F2 sin theta whole square. Now let me expand this. It is going to become F1 square plus F2 square cos square theta plus 2 F1 F2 cos theta, and this will become plus F2 square sin square theta. Now if I take F2 square common, then this will become F1 square plus F2 cos theta whole square plus F2 sin theta whole square. Hypotenuse, base, perpendicular. So according to Pythagoras, I can write this, right? R square equal to F1 plus F2 cos theta whole square plus F2 sin theta whole square. Now if I take F2 square common, then I will write it like this: sine square theta plus cos square theta plus 2 f1 f2 cos theta. Now what is this sine square theta plus cos square theta? This is equal to 1. This quantity is equal to 1. So from here, can I say R is equal to root over f1 square plus f2 square plus 2 f1 f2 cos theta? Can I say this? Can I say this? R is actually root over f1 square plus f2 square plus 2 f1 f2 cos theta. Yes. So this is the direct formula of this resultant R, which is the addition of f1 and f2. Now we have found out the magnitude of R, but what about the direction? When I say direction, I am asking you the angle. Okay, this angle, let's call this angle alpha. So I can also find this alpha. How can we find the alpha? From the same triangle, can we calculate tan alpha equal to perpendicular by base? Tan alpha equal to perpendicular by base. Can we calculate it? So alpha will be equal to tan inverse of f2 sine theta divided by f1 plus f2 cos theta. So what is this? This is the direction of resultant R. But let me tell you beta, this alpha is the angle between R and f1. The alpha is the angle between R and this f1. Let's say you want to calculate the angle between R and f2. Then you interchange them. Then you just simply interchange them. Instead of f2 you write f1, and instead of f1 you write f2. Okay. So here whatever formula we have written, that is the angle between resultant and this value f1. Okay. Chalo. Now let's solve a few problems in order to understand how we are going to apply this concept. Okay. Now there is another theory, another law of adding two forces that we are going to understand later. Okay. The law of triangle, that I will tell you later. Okay. So right now we are going to just add two forces using parallelogram law. You don't need to do all this in every problem. You just remember this formula. Okay. Whatever formula you have to memorize na, I will make 3 stars on that formula. Then you will understand that you have to actually remember the formula. Okay. So we will directly use this formula. Okay. Whenever we have a problem na of addition of two forces and we have to use parallelogram law, we will directly use this formula. R equals to root over f1 square plus f2 square plus 2 f1 f2 cos theta, and alpha is tan inverse of f2 sin theta upon f1 plus f2 cos theta. Okay. Chalo. So let's solve a few problems, and this is the first problem, a very basic problem. Okay. I just want you to understand how to put values in that formula. So two forces of 140 Newton and 260 Newton are acting simultaneously at a point, and the angle between them is 45 degree. Resultant of these two forces is. So this is MCQ question actually, not NET. So we have two forces of 140 Newton and 260 Newton. They are acting at a point and the angle between them is 45 degree. We need to find the resultant of these two forces. Okay. So here we have very basic question. We just need to use the formula. We'll put everything in this formula. F1 square plus F2 square plus 2 F1 F2 cos theta. Now we know the value of F1, we know the value of F2, we also know the value of theta. So F1 is 140, F2 is 260, and the angle theta is 45 degree. So tell me, what is the answer? Tell me what is the answer. I am getting 372.39 Newton. 372.39 Newton. It means the answer is A, right? The closest to my answer is A, 372 Newton. So I hope everyone is getting this. Here they are not asking you to find the direction of this resultant, they are just asking you to find the magnitude, and the magnitude is around 372 Newton. Okay, let's move on to another question. Yes, everyone solved this one. So let's move on to another one, shall we? Chalo. Now solve this one. The angle of the resultant of these two forces acting on the screw from positive x-axis is. This is your positive x-axis. They are asking you what will be the angle of the resultant with this axis. Let's solve this one. Interesting question, isn't it? So we have two forces, one is 2 kilonewton, one is 6 kilonewton. We need to find the angle of the resultant with positive x-axis. Okay. Now what we are going to do is, we are going to use our formula, and when we will use our formula, we will get the angle between resultant and one of these forces. Okay. The resultant between these two forces will be somewhere like this, na? If I apply parallelogram law, resultant will be somewhere like this. Okay. If I apply parallelogram law, see, it will be something like this. So resultant is something like this. Okay, you don't need to actually do this, but I want you to understand everything, so I am drawing this. Okay, so this is the resultant. Now what I will do is, I will find the angle between resultant and 2 kilonewton, alpha, and then I will add 45 degree. So I will get the angle from x-axis to r. So let's find the value of alpha. So alpha will be equal to what? Tan inverse of F2 sin theta upon F1 plus F2 cos theta. Now here you need to be careful about which one will be F1 and which one will be F2. Understand this. I told you when we were writing the formula alpha that it is the angle between resultant and F1, right? So I am finding the angle between R and 2 kilonewton. So my 2 kilonewton will be F1, right? This one will be my F1 and this one will be my F2. Then this is alpha. So apply this formula. So it will be F2 means 6 kilonewton. Theta is how much? What is the angle theta? Angle theta is the angle between them. So this angle theta will be how much? 180 minus 60, 120, 120 minus 45, 75 degree, right? So your theta is 75 degree. So alpha will be equal to tan inverse of 6 sine 75 divided by 2 plus 6 cos 75. So you will get the angle alpha. So how much are you getting? 6 sine 75 divided by 2 plus 6 cos 75. How much are you getting? 58.49 degree. Are you getting this much? 58.49 degree. Are you getting this much? 58.49 degree. But this is not our answer. See, they are asking you to find the angle between x-axis and resultant. So what will be this angle? Our answer will be this. Let me call it beta. So what will be beta? Beta will be 58.49 plus 45. So what is beta? It is 103.49 degree, almost 103.5 degree, right? So our answer will be D, 103.5 degree. Yes. So a lot of people are going to make this mistake. They will put B as the answer because they have calculated this alpha. Whatever they are getting, they will just put that. But beta, they are asking you to find the angle of resultant from the positive x-axis. So we have found the angle between resultant and 2 kilonewton, which is alpha. Then we will calculate beta, which is angle between x-axis and resultant. So 45 plus alpha will be beta. I hope that you liked this question. So they are going to give, see, in GATE exam, they will ask you questions like this only. They will not ask you directly this type of question. They might give you these questions for 1 mark. But in 2 marks question, you will get these type of questions where they will twist the question in some way. Okay. They want you to make mistakes. So in order to avoid mistakes, you have to be very careful while solving the problems. Chalo. So shall we move on to the next question? Chalo, let's solve this one. The angle of the resultant force from x-axis in clockwise direction. It's a similar question. Now this time I want you to solve this on your own. Angle of the resultant of these two forces from x-axis in clockwise direction. Try to solve this on your own. So in this problem, again we have two forces, 600 Newton and 400 Newton. Okay. So if I find the resultant of these two forces using parallelogram law, the resultant will be something like this. This is R. Okay. Now this is going to be your alpha. So how can we find alpha? Again using the formula tan inverse of F2 sin theta upon F1 plus F2 cos theta. Now in this case, what is my F1? So this will be my F1 because I am calculating angle between resultant and this is my F2. So what will be my formula then? Tan inverse of 400 sin theta is 60 degree divided by 600 plus 400 cos 60 degree. So from here I will get my alpha. (23.41 degree). 23.41 degree. So this is the angle between 600 Newton and R, but I want to calculate the angle from x-axis and R. I want to find this beta. So beta will be equal to how much? whatever you are getting alpha plus this 20 degree. Now, if this is 60 degree, then this will be 20 degree. Sorry, 30 degree. So sorry, 30 degree. This is 60 degree. So this must be 30 degree. So beta will be alpha plus 30 degree. Okay. So 23.41 plus 30 degree. So your beta is 53.41 degree. Yes. So answer is 53.41 degrees. Okay. Chalo. So now you know how to calculate the magnitude of the resultant as well as the direction of the resultant. Chali. Now the next thing, again another question. Two forces of, another one is MCQ. This is also MCQ, not NAT. Sorry for this. Two forces F kilonewton and 2F kilonewton act on a particle. If the first force is increased by 12 kilonewton and second force is doubled, line of action of the resultant force remains unchanged. Value of F is. Now this is an interesting question. Okay, understand what they are saying. We have two forces F and 2F. They are acting on a particle. First force means F is increased by 12 kilonewton and second force means 2F is doubled, but the line of action remains same. Okay, let me show you by diagram what they are saying. So let's say that we have two forces, one is F and another is 2F. One is F, another is 2F, and they are acting at some angle. Now their resultant is this. This is F, this is 2F. Now they are saying that if I increase F by 12 kilonewton and if I double 2F like this, the line of action of the resultant remains same. So line of action means what? Line of action of resultant remains same means what? Line of action remains same means this angle will remain same, right? This angle will remain same. If the line of action remains same means this angle alpha will remain same. Okay. So now we have increased this by 12 kilonewton, F plus 12, and we have made it double 4F. But the line of action is same means the angle is still alpha. So they are saying that alpha remains same. Now what is alpha? Alpha is tan inverse of F2 sin theta upon F1 plus F2 cos theta. So it means if my alpha remains same, this value remains same, then only my alpha will remain same, right? This value in both cases must be same. Okay. So now what you need to do is you need to equate these two things. So F2 sin theta. Now in my first case, what is F2? 2F. Let's say this is 2F sin theta divided by F1 is F plus 2F cos theta. In second case, what is my F2? 4F. So 4F sin theta upon F1 plus F2 cos theta. So it will be F plus 12 plus F2 means 4F cos theta. Now, this sin theta will be cancelled. This f and f will be cancelled. This will become 2. So if I cross multiply this, it will become f plus 12 plus 4f cos theta equals to 2f plus 4f cos theta. Now again this 4f cos theta will be cancelled. F plus 12 equals to 2f. So it will become 12 equals to 2f minus f. So your f will become 12 kilonewton. Yes. So the answer is which one? B. 12 kilonewton. So it was an interesting question, right? The most important thing in solving this question was how we are going to approach this. What is the thing that you need to do in order to make this line of action remains unchanged? Okay, so you had to decode this line. You had to decode this thing. Line of action remains unchanged. So line of action remains unchanged means the angle of this line of action with this f will remain same. So if this was alpha, this will also be alpha. So you have to just equate both alpha and you will get the answer. Yes. Chalo. Now after finding the resultant of two forces, now we are going to reverse it. And reversing this process of finding the resultant of two forces is known as resolution of a force. What do we mean by resolution of a force? In some problems, when a force is acting in a particular direction like this, you might have to break this force into two components. You will find the significance of this in problems. When we will solve problems, then you will understand in which case we have to do this. So resolution of a force means, resolving a force means breaking this force into two components. So it is a process which is inverse of finding resultant. What we were doing in resultant, we were adding two forces and we were making a single force, right? We were combining two forces into a single force. Here we are going to do the reverse of it. We are going to break this force into two forces. So how we are going to break this force, beta? In the same way we were finding the resultant. Let's imagine that this force is the resultant of two forces. Now if it is resultant of two forces, it means that this is your diagonal. So the two forces will be something like this. If this is the diagonal of those two forces, then can I say those two forces are something like this? Or in other sense, you can say that you are finding the projection of this force on x-axis and y-axis. Let's say I want to break it in x and y component. So I am finding the projection of this force on x-axis and y-axis. So one projection will be like this. And one projection will be like this. So this is the y projection and this is the x projection. Okay, so let's say this force is F. So what is this? This is Fx and this is Fy. Now, if this angle is theta, then your Fx will be equal to how much? Then your Fx will be equal to F cos theta. And your Fy will be equal to F sin theta. Now understand, in order to remember which one will be F cos theta, which one will be F sin theta, just understand this rule. Whichever force is making the angle with F, that will be the cos component. So this force Fx is making the angle theta with F. So Fx will be the cos component and Fy will be the sine component. Okay. So this process is the reverse of finding the resultant. In resultant, we are combining two forces into a single force. In resolving the force, we are breaking this force into two different forces. Okay. So we are reversing the action of the finding the resultant. Okay. Now it is not necessary that you will always resolve the force in x and y component. Okay. For example, let's say that we have this question. Let's say we have a force like this and we have to find the component along some other direction. Let's say we have to find the component along this axis and this axis. Okay. Do you understand my question? I am saying that a force is acting like this. Let me make it like this. A force is acting like this and I want you to break the force into two components along this direction and this direction. Not in our usual x and y direction. Along this direction and this direction. So what you are going to do is, in the geometry you will find this angle. They will give you this angle. Okay. Now, all you need to do is use the same concept. So what we have done, we have found the projection. So this is, let's say this force is F. So this is F cos theta and this is F sin theta. So it is not necessary that you will always resolve the force along x and y direction. They can ask you to resolve the force along any axis. Okay, it depends upon the question. Okay, let's solve one question on this. Okay, this is a very interesting question. Understand this. It's a very practical question. To study the effect of 2 kilonewton tensile force in cable on the beam, we have this beam. Okay, we need to, let's say, find stresses in this beam. So to study the effect of this force, we need to find two equivalent forces, two components of this force along this axis and perpendicular to this axis. Okay, whenever we calculate stresses in beams, the force can either be along the axis or perpendicular to the axis. Okay, so we can't find the stress in beam if the force is acting at an angle. So that's what they are saying, that in order to find the effect of this force on the beam, we need to find component of this force along the axis and perpendicular to the axis. Okay, now this question is your homework, or in other words, assignment. I want you to solve this question and we will discuss the answer to this in the next class. So today we understood about the basic concept of force and the concepts related to forces. Principle of transmissibility, force is a vector quantity, addition of two forces, resolving a force into two components. Tomorrow we are going to understand a very interesting concept related to force, and that is moment. And we will solve lots of questions related to moments also. We will understand the basic concepts related to moment. What is a moment? What is a couple? What is Varignon's theorem? And we can also resolve a force into a force and a couple. So we are going to understand all these concepts in tomorrow's class. So I will see you tomorrow at the same time. Till then, bye-bye and thank you so much.